Okay, so now let's proceed. So we are from explaining this particular question. So now we come to question B. So add the following numbers in 1's complement using 8 bits. Determine whether an overflow has occurred. So now here the key point is that we are adding in 1's complement, okay, because we already now know about 8 bits. So let's do that now. So first of all, what are the values which we've been given? So we have 25 and negative 56. 25 and negative 56. Okay, 25 and negative 56. So the number which we've been given is 25 and negative 56. Okay, so this is the question. We're adding it in 1's complement. So for each and every question, we'll be starting with the powers of 2. So why am I even starting at the find? Okay, so what is 1 times 2? We said it's 2. 2 times 2, we have 4. So there we put the 4. 4 times 2, we have 8. 8 times 2, we have 16. 16 times 2, we have 32. 32 times 2, we have 64. Then 64 times 2, we have 128. Okay, now so in this particular case, we need to understand. At first I said a complement is only affected when a number is a negative. So in this case, the number which will be affected is negative 56. So let's start off with the number which is not affected, which is 25. So 25 in binary is just 16 plus 8, which is 24, and then plus 1, which is 25. So we have our 25 in binary. So let's just represent that 25. Now we have our negative 56. So before even going to the complement part, we just need to convert 56 into normal binary. So 56 will start at 32 plus 16, we have 48, plus 8, we have 56. So that's our 56 in binary. So here we just represent this as 56. Now the question is telling us to say we need to add these two numbers in 1's complement. For us to do that, we need to convert 56 in 1's complement because it has a negative, so it's affected. So in this case, we know that a 0 become a 1 and a 1 will become a 0. Okay, sorry for that. So this one becomes a 0, these zeros become 1's. So this is our final outcome. So because it's just 1's complement, there's no need to go into 2's complement by saying plus 1. So this is our 25 and this is our negative 56 in 1's complement. So now we can add these two numbers. So let's do that. So to add these two numbers, I'll just write them here. We'll start with our 25, which is this. So we say 0, 0, 0, then 1, 1, 2 zeros, and a 1. That's our 25. Now we get this final outcome for negative 56 in 1's complement, so which is a 1, 1, 0, 0, 0, and 3 1's. Okay, so remember we are adding, so I'll say plus. So now let's come up with our final answer. So here we say 1 plus 1. Remember it's a 0, we carry a 1. So 1 plus 1 again, it's a 0, we carry a 1. 1 plus 1, it's a 0, we carry a 1. 1 plus 1, it's a 0, we carry a 1. 1 plus 1, it's 0, we carry a 1. Then 1 plus 0 is just 1. 0 plus 1, 1. 0 plus 1, 1. Okay, so there we have it. Now, remember, we need to determine whether an overflow has occurred or not. So, what's the bigger number here? 25 or 56? Is 56. So, for us to come up with this value, we started here where there is this first one. So, put a demarcation there, like that. Okay, so we are demarcating two things here, so we'll do the same even here, like that. So this is our sign and this is our magnitude. Remember, what determines whether positive or negative is the sign. So we said the 1 represents a negative. So let's first find out what's the outcome of this for us to understand what's happening. So what is 25 plus 56? So this is the same as 25 plus, remember this is what? Negative 56. So in mathematics, we know positive times negative, we get a negative. So we say 25 minus 56. So 25 minus 56 in general terms is the same as 56 minus 25, but we maintain the sign of a bigger number. So we say 56 minus 25. Okay, so this is 6 minus 5, which is 1, then 5 minus 2, which is 3. Now the bigger number is 56. So instead of saying 31, we'll say negative 31. So as I said earlier, if you want to really prove what you are doing, what you can try to do is try to convert 31 in binary first so that you understand. So we can do it first here by saying what is 1 times 2, it's 2, times 2 we have 4, times 2 we have 8, times 2 we have 16, times 2 we have 32, then we know times 2 there we have 64, times 2 we have 128. So remember, here we are trying to just convert that negative 31 in 1's complement. So to get 31, it's 16 plus 8, which is 24, plus 4, which is 16 plus 8, we have 24, so here 28, then 30, then 31. Okay, so that's our 31. So remember, 31 is not just 31, but it's a negative 31. So because it's a negative now, we need to apply the 1's complement by changing these zeros to become 1's, and 1's become zeros. So this is a 1, now this is a 1, this is a 1, and the rest to be zeros. So you can see that by doing this, we get the same 111 and the rest are zeros with the first method we did here. Now here, since we are saying this is the sign, so we can see that the number we are expecting is a negative because a 1 represents a negative, and here we are also expecting a negative because what we expected is our outcome. Therefore an overflow hasn't occurred. So in simpler terms is that when you are adding two numbers or you are subtracting them, then you are expecting a positive and you get a positive, there is no overflow. Or you are expecting a negative and you get a negative, there is no overflow. So that's how we do this particular thing. So let's just verify if that is correct. So you can see, so I won't go through these steps again. I'll just highlight the final answer. You can see that, okay, truly we have 3 1's, then the rest are zeros. So my name is Asoko James, representing KMU Cybersecurity Tutorials. Make sure you continue watching till we are done with this test 2 in terms of binary.